Yes, it is permissible to run a ground fault circuit interrupter GFI circuit and a non-ground fault circuit interrupter circuit in the same conduit to supply pool equipment. However, there are several important considerations to ensure safety and compliance with electrical codes. Firstly, all wiring must comply with the National Electrical Code, NEC, and local regulations. This includes using the correct type and size of conductors for the intended application and voltage. Secondly, the conduit must be properly sized to accommodate all conductors, including grounding conductors, without exceeding the conduit fill capacity. The NEC provides tables for calculating conduit fill based on the type and size of conductors. Thirdly, all circuits must be properly grounded. The grounding conductor for each circuit must be run with the circuit conductors in the same conduit. This ensures a low impedance path for fault current to return to the source, which is essential for proper operation of ground fault circuit interrupters and for safety. Fourthly, the ground fault circuit interrupter protection should be provided for all circuits serving pool equipment as required by the NEC. This includes circuits for pumps, heaters, lighting, and other equipment. Fifthly, the equipment grounding conductors must be properly sized and connected to all metal parts of the pool equipment, including the pump motor housing, heated chassis, and any metal conduit or enclosures. This helps to minimize the risk of electric shock. Sixthly, it is important to use proper wiring methods and installation techniques to ensure that the circuits are protected from physical damage and environmental factors such as moisture and corrosion. This may include using liquid-tight conduit and fittings for underground wiring. Seventhly, all electrical work should be performed by a qualified electrician who is familiar with the NEC and local electrical codes. This helps to ensure that the installation is safe and compliant. Eighthly, it is essential to properly label all circuits and equipment. This helps to identify the circuits and equipment and to prevent confusion during maintenance or repairs. Ninthly, regular inspections and testing should be performed to ensure that the electrical system is operating properly. This includes testing ground fault circuit interrupters to verify that they are tripping properly. Tenthly, the NEC Article 680 covers the requirements for swimming pools, fountains, and similar installations. This article provides specific requirements for grounding, bonding, wiring methods, and equipment. 11thly, when running multiple circuits in the same conduit, it's crucial to consider voltage drop. On-conductor runs can cause voltage drop, which can affect the performance of the equipment. The NEC provides guidelines for calculating voltage drop and for selecting conductors that are sized appropriately to minimize voltage drop. 12thly, it's also important to consider the ampacity of the conductors. The ampacity is the maximum current that a conductor can carry without exceeding its temperature rating. The NEC provides tables that specify the ampacity of conductors based on their size, insulation type, and installation conditions. 13thly, when installing ground fault circuit interrupters, it is important to follow the manufacturer's instructions. Ground fault circuit interrupters are sensitive devices and can be affected by improper installation or wiring. 14thly, it is also important to ensure that the ground fault circuit interrupters are properly tested after installation and on a regular basis thereafter. This helps to ensure that they are functioning properly and will protect against electric shock. 15thly, the NEC requires that all ground fault circuit interrupters be tested at least once a month. 16thly, it is important to use the correct type of ground fault circuit interrupter for the intended application. There are different types of ground fault circuit interrupters for different applications, such as personnel protection and equipment protection. 17thly, it is also important to ensure that the ground fault circuit interrupters are properly sized for the load. The ground fault circuit interrupter must be able to handle the full load of the circuit. 18thly, when running multiple circuits in the same conduit, it is important to ensure that the conductors are properly identified. This can be done by using color-coded conductors or by labeling the conductors with circuit numbers. 19thly, it is also important to ensure that the conduit is properly supported. The conduit must be supported at intervals that are specified in the NEC. 20thly, when installing conduit underground, it is important to ensure that it is buried at the proper depth. The NEC specifies the minimum burial depth for conduit based on the type of conduit and the location of the installation. 21st, it is also important to ensure that the conduit is protected from physical damage. This can be done by using a concrete encasement or by installing the conduit in a protected location. 22nd, when installing conduit in wet locations, it is important to use liquid-tight conduit and fittings. This will help to prevent water from entering the conduit and damaging the conductors. 23rd, it is also important to ensure that the conduit is properly sealed at all connections. This will help to prevent moisture and other contaminants from entering the conduit. 24th, when installing conduit in corrosive environments, it is important to use corrosion-resistant conduit and fittings. This will help to prevent the conduit from corroding and failing. 25th, it is also important to ensure that the conduit is properly bonded to the grounding system. This will help to ensure that the conduit is at the same potential as the grounding system, which will help to prevent electric shock. 26th, when running multiple circuits in the same conduit, it is important to consider the potential for electromagnetic interference. Electromagnetic interference can disrupt the operation of electronic equipment. 27th, it is also important to ensure that the conduit is properly installed in accordance with the manufacturer's instructions. The manufacturer's instructions will provide specific information on how to install the conduit properly. 28th, when installing conduit, it is important to use the correct tools and equipment. This will help to ensure that the conduit is installed safely and properly. 29th, it is also important to follow all safety precautions when working with electrical equipment. This includes wearing appropriate personal protective equipment, such as gloves and eye protection. 30th, it is important to de-energize the circuit before working on it. This will help to prevent electric shock. 31st, it is also important to test the circuit to ensure that it is de-energized before working on it. This can be done with a voltage tester. 32nd, it is important to be aware of the potential hazards of working with electricity. Electricity can be dangerous if not handled properly. 33rd, it is also important to be familiar with the NEC and local electrical codes. The NEC and local electrical codes provide information on how to install electrical equipment safely and properly. 34th, it is always best to consult with a qualified electrician if you have any questions about electrical safety or installation. 35th, remember to always prioritize safety when working with electricity. By following these guidelines, you can help to ensure that the installation is safe and compliant.